Okay, so something we want to revise is recurring decimals as fractions. So we know from previously that 0.333333, etc. can be written as 0.3 with a dot, and it's also written as a fraction as 1/3. But how do we get to the fraction? How do we do that? How about 0.44444 ... That is definitely not equal to 1/4. We know that because 1/4 is 0.25. So what is it? So how do we figure that out? So for example, if we let a equal to our 0.3333, then if a is that much, then what is 10a equal to? That would equal to multiplied by 10, and if I multiply that by 10, it's like moving the decimal point by 1. So now we have 3.33333 forever. Now when we have this setup over here and we say a is equal to 0.333333 and 10a is 3.3333, one really cool thing we can do is subtract these two down. So if I use another color to show you so it's a little bit more clear. So what happens when I have 10a minus a? I will obtain 9a. What happens when I have 3 these guys minus the same guys? Well, I'm going to have, well, this take away this is 0. That take away that is 0. That take away that is 0. So all the little 3's behind here cancel out, but 3 take away 0 is 3. Now, I want to figure out what a was because a is 0.33333. Let's figure out what a is. We can get rid of the 9 by dividing both sides by 9. And now I'm left with a equals 3/9. But I know simply that 3/9 is just dividing by 3 on both sides. It's just 1/3. That is exactly what we wanted. And we now have a method. Now if we can do this, can we figure out the 0.4444 forever? Let's have a look. We'll do the exact same method. So we let any pronumeral, let's call it a. We could have used x if we wanted to. It doesn't matter. Equals to 0.4444 forever. And we let 10a be equal to, move the decimal point once, 4.44444 forever. And then when you subtract these two, you end up obtaining 9a equals that, and that becomes 0, just 4. So dividing by 9 on both sides, we now have a is equal to 4/9. So if you put that into your calculator, 4 divided by 9 gives you 0.444444. And I can show it and prove it to you. So 4 divided by 9 is equal to, as we expected, 0.444444 forever. So that's how we do it. Now, what happens? The next question is, what happens if I get something that has 2 digits that repeat itself again? Now this time, if I get 10a, then the problem is 10a is 2.52. Now these don't match. Can you see that 5 take away 2 is not going to give me 0? So that's not the way to go. So what can we multiply so that it disappears? What can we multiply by to get rid of the 2525? We can multiply by 100. Because when we multiply by 100, we move the decimal point twice, we get 25.252525. So we have 25.252525 forever. So when we subtract this time, minus 100a minus a, 100 minus 1 is 99a's, 25.252525. This minus this is 0. There's another 25 forever. And 25 minus 0 is 25. So now dividing by 99 on both sides, we obtain a is equal to 25/99. And again, surely we can prove that using a calculator to double check. 25 divided by 99 is surely 25252525 forever. So one last question, and I'm sure you'll be able to guess how to do the last one. Let's pick, what color should we do? Red. What happens when we have 3 digits that repeat? 0 point anywhere and 3 digit 1 2 3 1 2 3 1 2 3 forever. How do we do this? Again, we let it a equals that, and this time because we have to move the decimal point 3 times, you guessed it, we have to get 1000 a equals 123.123.123.123 forever. Now when we subtract that, we get 999a equals 123, and therefore a is equal to 123 over 999. I know seems to be a pattern here of lots of nines, but sometimes it doesn't equal to a 9 just like this. So be very, very careful. So that's how you do recurring decimal.